So I just picked a few problems off the day 13 review to do with you. The first one I selected was number 3, where I have the sine of 2x on the left side and 2 tangent of x over 1 plus tangent squared x on the right side. And the directions say prove the identity. So this is one of the first things we did in chapter 9, and I just want to get the left side equal to the right side. So the right side looks a little bit more confusing than the left. So I'm going to start playing with that. I'm going to go ahead and write the right side in terms of sines and cosines. So 2 sine x over cosine x, and then divided by 1 plus sine squared x over cosine squared x. All right, well, I have this 1 here, and I know that I need common denominators. So you're going to have to multiply this by a cosine squared over a cosine squared. And look what you're going to get in the numerator. You're going to get 1. So this is 2 sine x over cosine x divided by cosine squared x plus sine squared x is 1. And then I have cosine squared x in the bottom, in the denominator. Well, when I have this fraction down here, 1 over cosine squared x, I'm going to multiply by the reciprocal. And then you get 2 sine x over cosine x times cosine squared x over 1. And then what happens is this cosine squared gets rid of that. And then what you have is 2 sine x cosine x. And if you look at your chapter 9 formula bank, this does equal sine of 2x. So checkmate. We got her. All right, the next one that I chose to do was number 12. I wanted to do it one with tangent. All right, so I want to get this entire mess over here on the left side of my equal sign. So here's the equal sign. I want that to be proven to be equal to tangent of x. Now, look over here in pink. This is our addition formula for tangents. So this is a subtraction problem, but we call it the addition formulas. That's on your formula sheet. The tangent of s minus a t is equal to tan s minus tan t all over 1 plus tan s tan t. This is, again, one of the first formulas we started playing with. Okay, so what I'm going to show you is when I'm looking at this problem in orange here, if this was my s, and y was my t. Do you see how I have what's in pink? So I'm going to write tan s minus t. But instead of the s, I'm going to write x plus y. And instead of the t, I'm going to write y. And now the y's cancel, and you just get tan x. Checkmate again. So we just proved 2 identities. And these are just a couple of the problems from review. And obviously, contact me if you want me to do more. All right, the next type of problem we started doing in this chapter is we solved equations. So I want to make sure that 1 plus sine of x is equal to cosine of x, and I want to know what values of the x, what angles would make that happen. All right, so what I'm going to do right now is I know that I have to get everything in terms of sine or everything in terms of cosine. And I'm going to get everything in terms of sine. And the way I'm going to do that is I'm going to square both sides because I know cosine squared x is 1 minus sine squared x. So over here on the left side, we have to FOIL that out. And then when you do, you would get 1 plus 2 sine of x plus sine squared x. And over here, cosine squared x I can write as 1 minus sine squared x. Okay? All right, so now I'm going to get this equal to 0. So I'm going to add the sine squared x, so I will have 2 sine squared x's on the left, and I will subtract the 1. The 1 is gone. So you're going to have 2 sine squared x's after I add the sine squared x over here, plus 2 sine x equal to 0. All right, and now what I want to do is solve like this is simply just like 2x squared plus x equal to 0. So you would factor out, plus 2x, sorry. So you would factor out a 2x. So that's exactly what I'm going to do. I'm going to factor out a 2 sine x. And then I will get a sine x plus 1 equal to 0. So that means that 2 sine x is equal to 0, or sine x plus 1 is equal to 0. Well, 2 sine of x equal to 0, I need sine of x equal to 0. So where is sine of x equal to 0? So if we go over here, 1, 0, negative 1, 0. So the angle of 0 has the sine of x equal to 0, because remember the sine is the y coordinate, and pi. And we will check these answers in a second after I'm done. Here, where is sine of x equal to negative 1? Down here at 0, negative 1. So that's 3 pi over 2. All right, so like I said, we do have to check our answers. Okay, so how do we do that? We go back to the original equation and we plug in these angles. So is 1, I'm going to check 0 first. 1 plus sine of 0, does that equal cosine of 0? Well, cosine of 0 is equal to 1. And sine of 0 is equal to 0. And then I get a 1, so yes, we will keep x equal to 0 for the angle of 0. Let's check pi. 1 plus sine of pi, does that equal cosine of pi? Well, cosine of pi is equal to negative 1, and the sine of pi is equal to 0. So this one does not work. So we have to cross off an extraneous solution of pi. Let's check 3 pi over 2. Is 1 plus sine of 3 pi over 2 equal to the cosine of 3 pi over 2? Well, the sine of 3 pi over 2 is negative 1, and the cosine of 3 pi over 2 is 0. So 0 equals 0. Check. We will keep 3 pi over 2. All right, the next two problems that I chose were 64 and 77. All right, so where is the cosine inverse? What angle would get me negative root 2 over 2? Well, first off, the cosine inverse has a restriction from 0 to pi. Okay, so that's what we've been doing. And I know that it's not going to be quadrant 1 because I have negative root 2 over 2. Okay. All right, so right here, negative root 2 over 2, okay, that is going to be a reference angle of pi over 4. So that is 3 pi over 4. And that is the answer to number 64. Okay, last problem I did was number 77 that I wanted to do with you. Okay, so tan inverse. Well, tan inverse has a restriction from negative pi over 2 to pi over 2. Okay, so you can only report angles negative pi over 2 to pi over 2. All right, so where is tangent negative? Well, not in quadrant 1. Okay, it is negative in quadrant 4. So we will go ahead and use quadrant 4. And where is it negative 1? That would be a reference angle of pi over 4. Now, remember, that is 7 pi over 4, but that is not in the restriction from negative pi over 2 to pi over 2. Okay, so the answer is you have to report negative pi over 4, the negative angle. And then obviously the sine of negative pi over 4 is equal to the sine of 7 pi over 4, and that's negative root 2 over 2. And that is the answer to 77.